Hi, everyone, and welcome to the introduction to Apptainer and Singularity. My name is Marco Mambelli. I work at Fermilab, and on behalf of the High Energy Physics Software Foundation, I will be presenting this course to you. HSF has many other self-study guides that you can access by clicking on the link here on the top left of the page. So if you're interested, just have a look. But now let's get back to the introduction to Apptainer and Singularity. In this course, you will learn about containers, why Apptainer is an ideal container solution for scientific computing, and you will learn how to use it to do your work and to share it with others. Let's jump to the introduction. Here you will hear what issues motivated the creation of Apptainer and Singularity, what are the differences between Docker, Apptainer, and Singularity, and you will learn the design goals behind Apptainer and Singularity. Working with containers. So containers are packages of software that encapsulate a system environment. An OS level virtualization is delivered in a container, and any program running on it will use the contextualization isolated inside the container. They have the advantage that you can build a container on any system, your laptop, for example, and then execute it anywhere as far as the platform compatible with the container engine that you are using. Concepts as reproducibility, preservation, and distribution are important in the high-energy physics community, and the containers provide a solution totally compatible with such concepts. The version of some specific software used to perform an analysis can be preserved in a container, with exactly the same environment used at that time. A legacy software with binaries only available for an outdated operating system can be executed inside a container. And all the necessary packages to process data can be easily distributed in a container, independently of the operating system available on the other side. If you're interested in learning more about containers, you can just simply Google and you will find plenty of resources. For example, Google itself has some explanation about container. IBM as well has an explanation about what containers are, which are their benefits. And Docker, the company that actually invented these containers, has also a very nice explanation that talks about container and tells you a little bit about the difference between containers and virtual machines. There are different solutions to package things and make them portable to run in different places. The virtual machines use hypervisors. It's a software that's running the virtual machines. And then it's virtualizing everything, the full operating system, and sometimes even the hardware. So they are more flexible, but they are also heavier to run, and they require a lot of more disk space and resources. Container, instead, they are a solution that's based on the Linux operating system. And what it's doing, it's virtualizing only the upper level of the operating system. You can see a table with the standard division of the operating system in system space, the kernel mode, and the user mode or user space. The first one has all the drivers or the part that interact with the hardware, all the protected primitives that allow to share the machine between different users and several abstractions. And the upper layer have the libraries and the application that you're running. So containers, they share the same kernel that is in the base OS that's used to run the operating system and to run all the containers that are running there. And they only bring with themselves the libraries and the application, so only the upper parts. This is possible because the Linux kernel evolved with different abstractions and structures that make that easier. Specifically, around the beginning of 2000, they started providing different namespaces, which are abstracting the user ID, the file system, for example, or the network, or the communication between processes. And they can create sandboxes where each of these different namespaces is abstracted or not, depending on what your desired outcome. And they also provided another primitive, the C groups, that they will allow to share the hardware resources among different processes and make sure that different process groups are using only the amount of resources that you desire them to use. So container basically are providing a function similar to the one of virtual machine, but they are much lighter, and they use these features of the Linux kernel to make that possible. So we have many alternatives. So why using Apptainer or Singularity? Many solutions are available to work with containers. For example, Docker that we mentioned before, which is one of the first and the most popular platform, or the free open source software Podman, which provides almost identical functionality. However, the enterprise-based container framework were motivated to provide microservices, like running applications like a database or a web server or a service, an app. This is a solution that fits well in the model of the industry, where a system administrator with root privilege starts the container engine daemon and installs and runs the applications, each in its own container. Anyway, this is not so compatible with the workflow in high-performance computing and high-throughput computing, in which usually complex applications run exhaustively using all the available resources and without any special privilege. Apptainer Singularity is a container platform created for HPC and HCC use case. It allows to build and run containers with just a few steps in most of the cases, and its design presents key advantages for the scientific community. So here you can see these tables that can show you how working with systems that are in distributed computing and high-performance computing, it's always possible within Singularity, while many of the other alternatives are not available. And specifically, it's based on a single file container image, which is facilitating the distribution and archiving and sharing. It's able to run any modern system also to be installed without any root daemon or setuid privilege like a regular user. This makes it safer for large computer centers, which are resources. It preserves the permission in the environment, so the user outside the container can be the same as the user inside the container. Has a simple integration with resource managers and distributed computing frameworks because it runs as a regular application. So it's really a regular program. And then finally, last but not least, has minimum overhead. So there are no extra processes after the initialization. Apptainer disappears and it's taken over by your actual program. For people familiar with it, it's using like the execv primitive so that the process is actually replaced by the other one. So this is very useful for high throughput and high performance computing. If you are anyway still interested in running containers with other solutions like Docker or Podman, we suggest to look in the other training from HSF that's linked here, and that will give you an overview of this system, the introduction to Docker and Podman. So Singularity, like I said, it's providing a workflow where you build your images right in your experimental environment through modifying a container or through using recipe, and then you send them to the place where you are running, like in a big computer cluster, or you share them with other people so that they can run exactly the same research that you're using. So I've been mentioning so far the names Apptainer and Singularity. In this lesson, we'll see the name Apptainer or Apptainer/Singularity and the command Apptainer. As stated in the move and renaming announcement that is linked here, Singularity is Apptainer. Currently, there are 3 products derived from the original Singularity project from 2015. Singularity Pro, a commercial software by C Labs. Singularity Community Edition, an open source Singularity supported by C Labs. And Apptainer, an open source Singularity renamed in 2021 and hosted by the Linux Foundation. As of spring 2024, all 3 Apptainer Singularity versions are compatible and practically the same. There are different roadmaps, though, and there is the hope that in the future they will join forces, but it's not currently the case. So if you are curious and want to understand more how this came to be, you can read the history of Singularity in Wikipedia. It's a very nice article that will explain you this example of software development and history. So we are following Apptainer. That's the most adopted variation in the scientific community. So we are using the Apptainer command. And if you're using Singularity Pro or Singularity CE, just replace the command Apptainer that you see in this tutorial with Singularity. And we are using the environment variable Apptainer underscore and Apptainer env underscore, which are prefixes used for environment variable. If you are using Singularity or CE or Singularity Pro, you can replace that with Singularity underscore or Singularity env underscore. If you have older scripts using Singularity, you've been using it already, and the Singularity variables, anyway, don't worry, because since this was the previous name of Apptainer, Apptainer will work also with the Singularity command, an alias normally is defined, and has full compatibility with the previous Singularity environment. At the end here, you can find a link to the official Apptainer documentation. So you have documentation both for users and administrators, and it's a very thorough and covers all the arguments. So that's been the basis for most of these classes. And you're welcome to read there all the details. So in this introduction, we saw that Apptainer Singularity is a container platform designed for scientists. It's a single file-based container, and its images facilitate the distribution. And it's secure because the user inside the containers is the same as the user outside, and very high performant because it doesn't have any overhead of daemon or extra processes. So this module and the following one in this course are hosted on GitHub. So if you have any suggestion or feedback, you are welcome to open an issue and provide this to us. Thank you for following.